Welcome to clickmyproject.com. Now we are going to discuss about our product title, Recursive Approach to the Design of Your Parallel Self-Timed Order. Now we are going to discuss about our product abstracts. So in our process mainly we have considered about that pipelined orders using the single write data encoding process using the CMOS devices in the FinFET process. The circuit design mostly established for the flow of carry signals. In most cases of the dual rail carry conversion is used the internal bitwise flow of the carry outputs. These dual rail signals can be represented in more than two logic values or just one, and then therefore they can be used to generate the bit level acknowledgements when a bit operations is completed. Finally, completion is sensed when all bits acknowledgement signals get and receive the high values. This carry completion sensing the orders in our example pipeline order, which use the full order functional blocks adapted for the dual write carries. On the other hand, the completion order in the proposed it uses so-called about the logic and yearly completion. Select the proper response of the number is fixed delay lines. The logic of the implementations is so high fan is recommends delay incentive adders using the dual rail encodings. This adder of the asynchronous adders that assert the building constraints of operations. The correctly operate is the presence the bounded the unknown the gate and the wire delays. The delay is the variation of the DI adders in the DL ripple carry orders. The DI carry looked ahead adders the dual write encoding the assumption increase the complexities. So we will optimize the implementations. We use a DG MOSFET and a MOSFET and this PMOS NMOS, the combination of the dynamic logics of the designs. Therefore we example we using the 40 resistors the bed adders is presently the carry propagation generates the equations. The dual write encodings are not rather organized system the hierarchy of the tree of the this FinFET process. We will separate the automatically single pipeline the carry inputs, separate the propagations, initial delay and the gates of the circuit's path. Now we are going to discuss about the process of the flow diagram. We have give the input data bits. We all give the binary bits of zeros and so on the value high value of the process, and we go to the selection bit of the mux. So we choose the what level of the mux 2:1 process we have selected, and then going to the architecture implementation using the FinFET designing for the using the off order process. So we automatically we reconnect and reproduce the process. We generate the 2:1 max is automatically generated, and then selection part is automatically generated. The carry skip on the carry save order processing is all automatically generated, and then the off order completed the process. That detection unit is most processing the level. This process we have using the dual rail comparator, and then designing the processors PMOS and NMOS designing in the architecture. In this detection unit we get the what we using the last 2 digit of the complement of the output of the zeros or ones level, and the finally we get the performance analysis and the designing of the DG MOSFET and then FinFET processor using the LT spice we have propagation of the power and area specification of the how their leakage current and how we get the reduce the optimization of the area and frequency of the level. So that's level of the performance we get it. So the designing completion using the FinFET using the LT spice process. Now we are going to discuss about our product running procedure. We have implemented our project tool using the LT spice schematic tool. Our implementation for that just one application for the adder functions using the DG MOSFET and the CMOS functions. How 100% coding this process. I just opened this process. In the tool having the schematic, everyone is separated. The currently wireless we connected to the, and port node we connected to the each an input and output port. Finally this process completion unit of the full processing and completion unit. This level you have getting the initially adder functions and then feedback adder functions. So whatever we connect to this completion process. So this is the final output of the port. I am going to just running the processor. Just we after completing this process, we just going to the simulate the running the process. Just open the graphically away from so where we want how we will get this IC and this MOSFET and the PMOS and NMOS. How will produce? How will we generate the power? So we automatically just click on this here port. We generate the power voltage, and the same level on the click the shift button, you have get the voltage and the current values for the inverter of the processor. So this is the main method of the graphical unit. We will get the we give the input for the 5 volt. So how will we generate the voltage? I will be using the this level of the periodically generate the voltage, and how we will leakage the leakage current and the voltage. So with this graph is representing the level of the process. So 5 volt we generated. The last of the 3.7 and to 3.9 volt, the 0.27 volt is the drop. So the harmonic will generated. So we will give the added the filters like low pass and low pass filter. So it will be automatically remove the process. So this is another tool or good new tool for the LT space. We generate the adder, some designing tool for this process. Thank you watching our video.